So let's see how basically we solve a given numerical for any hashing. So let's say problem is given to you like this. Insert the given keys ki, let's say, at first free location from u plus I square modulo m. We have already explained about what is the meaning of u. U is nothing, it's basically the first position you get after applying a division method or remainder theorem. So this is my first position. And then I may be starting from 0 or you may start from 1. Because after getting 0, you'll be getting the same answer. But as the problem is stated, you start I from 0 to m minus 1. So we'll check from I from 0. And you need to find out division method to find out whether next available slot is there or not. Hash function is given as 2k plus 3. Try to understand this point. Key is given like 3, 2, 9, 6, 11, 13, 17, and 12. And table size is given like m equal to 10. So try to understand this question. First, table size m equal to 10 is given here. What are the key that we will be inserting into this table? These values are given here. And what is the hash function we will be using? That is h of k will be 2k plus 3. Means what? Let's say I want to insert 3. I will be using a function h of 3. H of 3 will give me what? 2 into 3 plus 3. That is 9. 9, and then I will apply my division method. And my division method is what states 9 modulo 10, because m is 10 here. 9 modulo 10 gives you what? It gives you 9 as a remainder. So you become 9. Fine. So u is nothing. It's a current position you got. Whether the current position is giving you the element to be searched or element to be placed, that gives the number of probe. If the current position u with 0, no more further movement, I is 0, let's say, then number of probe required is 1. If I am not getting an empty space by getting a current position u, then in that case you need to increase I further. And what is this formula here? This is quadratic probing. Means what? Next time I will become 1. Another next time I will become 2 square. That is 4. So I will first take u as a what is my current position. And then I will keep on increasing my I starting from 0 to m minus 1. If I am getting my result in 0 itself, empty slot in 0 itself, number of probe will be calculated as simple 1. Because I got my position and I got my element there also. So no more another probe is required. So number of probe required is only 1. So this is the explanation about how we will go about this kind of question. Same question may be given using the division method, but formula may be like linear probing. So you have to use what? U plus I modulo m. So in that case, you need to increase I in a fashion of 1, 2, 3, and so on, as I have explained in my last part of this hash video. So at last question states what? Calculate the total number of probes to search all the key elements. So you need to calculate the total number of probes required and also print the sequence of the data in the hash table. How you have organized this data into hash table. It is not like an array. Every data will be placed into particular slot by using its hash function and division method. For in case of any collision is there, then open addressing we will be using. So I hope a question is clear to all of you. How to solve this question then? I will first off make some column representing the value of key to be inserted. So key is my first column name. What is the hash function? Hash function, let's say, is given as 2k plus 3. In another question, this hash function may be given in a different way, 2k square plus 3. Then you need to write this h of k value here. The second column will be representing what? H of k, whatever h of k is given to you. Fine. And then you need to find out the location. So location will be finding from where? U plus I square modulo m. But before using this formula, you need to find out your u. And what is my u? My u is nothing. Whatever the value I got through hk, I will modulo this with my initial table size, that is 10. 9 modulo 10 always gives you as a 9. So here I have written 9. In second case, 7 modulo 10, you will be giving as 7. In third case, you can see here difference. 21 modulo 10 will give you modulus operator answer u as a 1. So I have written u as a 1 here. 15 modulo 10 will give remainder as 5. So my u become here 5. So I have stated in the very beginning also what is u? U is my current position. Now I will check whether my current position is giving my element. Then my probe is successful. I got my answer in one probe. So I will start checking from given value of I. I is given from 0 to m minus 1. So I will start without increasing anything. That is 0. I is 0. If first slot is available, yes, 9 is available because no element has been inserted till now. So I will insert here an element probe will be 1. I will insert 7. Next slot, I will insert 9 on first slot. I will insert 6 on fifth slot. Till now, there is no collision. Now, from here onwards, once I wanted to insert 21, I computed its HK value, Hessing key value. I got the answer 5, and I know 5 has already been occupied because 5 plus 0 square modulo 10 gives you 5. And this fifth location, if is already been occupied by 6 value, that is earlier key. And I want to insert 11 here again in fifth position. So I failed. What I have to do? I need to increase my I. So how I will increase my I? I will simply choose my this value, previous value, 5. That is my u plus I square. And what is my square? 1 square. So every time u will be same. So what you got basically? You got from here 25 modulo 10. 25 modulo 10 gives you first u. And that u you have written here 5. So 5 plus 0 square modulo 10 will also give 5. Okay. In first probe, you did not get location. In second probe, you find that yes, 6 position is available. None of the earlier element has occupied 6 position. So now I will allocate 11 on 6 position. So this is 2 probes is required either to insert or to find the location, or whenever you are searching for 11 during searching operation. So minimum probing required here is at least 2 by using this method. Similarly, for 13, you can see 13 HK value you are getting 29. So first you need to calculate 29 modulo size of the table is 10. So 9. So my u become 9. I will start my I from 0. So 9 plus 0 modulo 10. You got a position what? 9. But 9th position has already been taken by key value 3. So this is failed. I will keep increasing again my I. So I become 1 square. So 9 plus 1 square is again I got value 0. So 0th index still none of the key has been occupied. So now 13 will be allocated to which location? 0th index, and so 2 probes are required. First probe, it searched about 9th location which was already filled. Second probe, it looks for 0th location which was vacant. So it will put 13 there, and similarly for during searching also. Similarly here you can see for 7, you get a similar kind of answer. Now you try to understand about 12. I will explain about 12. So for 12, you got HK function as 27. 2 into 12 plus 3 will give you 27. Then 27 modulo 10 will give you your U, current position. The current location is giving what? 7. 27 modulo 10 gives you U as a 7. So I will start from 7, searching for 7. Whether 7 plus 0 square mod 10, that is 7 is available. Then first probe, I got no, 7 is not available. Already been occupied by E2. Okay. Then I will move for checking 7 plus 1 square. That is 8. 8 is available or not? I will see no, 8 is not available because earlier we have given 8 to key value 7. I will now make I again by I square. So I has been increased from 1 to 2. So that it's 2 square. U will remain same. U plus 4. That is 7 plus 4. So 7 plus 4 modulo 10, that is 11. I got a position 1. But this position 1 has already been occupied by this key value 9. So still I cannot allocate 12 to this location. So I will keep on increasing I till m minus 1. I will increase I to 3 square. So I got 9 plus 7, 16, 16 more 10, 6. But 6 is still being occupied by value 11. So I cannot allocate 6 to even to 12. I will keep on increasing, make it to 4, 4 is square, and then 7, 16 plus 7, 23, modulo 10, answer is 3. I got a position 3. Now I got a correct position where none of the previous keys or elements have been given a given location for that. So 12 will be occupied or will be allotted to which position? Third slot. Third slot in my hash table. But how many props required to get a 12th position? Even for searching 12th, whether 12th is available or not, you got first prop when I was 0. You got second, you got third, you got fourth. In fifth prop, you got a correct position. Or you can say you got a position where slot were empty. So total number of prop either to place an element 12 or whenever you are searching whether 12 is available or not in the hash table, at least you require how many props? 5 props. So in this way, you can calculate number of props for each and every key items in the given questions. And then you can find out the total number of props by summing up all those things. And you can sum up all those things, you will get answer as a 15. So how many number of props will be required? In roughly, you can see how many number of elements are there. 1, 2, 3, 4, 5, 6, 7, 8 elements are there. In order to search 8 elements, at max you require how many searching operations? 16. How many searching operations? 16. But for a particular element, you can see, let's say maximum 12 you want to search. You need not to make 8 probing. At max, you require how many probing? 5 probes. In 5 probes, you will get your answer about whether 12 is available or not available in the list. In this way, you can calculate the total number of props. And after the second part, you need to print the sequence of the data in the hash table. So that you can very easily, you can do it. And very simply, you can make table like this, that index 0 to 10 or 0 to 9, you can say, because size is 10, 0 to 9. Where you have placed key 3, you have placed where? Which location? 9th location. So 9th location, you can place 3. In key 2, you can place in 7th location.